Today, we're going to travel into the distant past and explore how our solar system came to be and how it changed over time. Thank you for watching. Sit back and enjoy. Our solar system is a collection of planets, dwarf planets, moons, asteroids, comets, and other objects that orbit a star we call the Sun. But how did it all start, and what made it look the way it does today? To answer these questions, we need to go back in time. About 4.6 billion years ago, when our solar system was nothing but a cloud of gas and dust. This giant cloud, called a nebula, was part of an even larger cloud that gave birth to many stars in our galaxy, the Milky Way. The nebula was spinning slowly, and as it spun, it flattened into a disk. Then something happened that triggered the collapse of the nebula. It could have been a shock wave from a nearby supernova, a powerful explosion of a dying star, or a gravitational tug from a passing star. Whatever it was, it caused the nebula to contract and heat up, forming a dense core at the center. This core became so hot and dense that it ignited nuclear fusion, the process that powers stars. This was the birth of our Sun, the most massive and brightest object in our solar system. The Sun's gravity held the rest of the nebula together, but it also blew away some of the lighter gas and dust with its strong solar wind. This left behind a ring of material around the Sun called a protoplanetary disk, or solar nebula. This protoplanetary disk was the nursery of the planets. It was made of gas, dust, ice, and tiny particles. Over time, the force of gravity, along with condensation, electrostatic attraction, and turbulence would slowly cause the material to come together and form larger chunks called planetesimals, which are the building blocks of the planets. As the disk spun around the Sun, the planetesimals collided and stuck together, forming larger and larger bodies. Some of these bodies grew big enough to attract more gas and dust with their gravity, becoming the seeds of the planets. The closer to the Sun, the hotter and drier the disk was, so the planets that formed there were mostly rocky and metallic, like Mercury, Venus, Earth, and Mars. These are called the terrestrial planets, rocky planets, or the inner planets. The farther from the Sun, the colder and icier the disk was, so the planets that formed there were mostly gaseous and liquid, like Jupiter, Saturn, Uranus, and Neptune. These are called the Jovian planets, or the outer planets. Jupiter and Saturn also belong to a category known as gas giants, while Uranus and Neptune are considered ice giants. The Jovian planets also have rings and moons, some of which were as big as planets themselves in the past. But the formation of the planets was not a smooth and peaceful process. It was chaotic and violent, involving many changes, collisions, impacts, and migrations. For example, scientists believe that Earth was likely hit by a Mars-sized object in its past, which knocked off a chunk of its mantle and created the Moon. Mars was stripped of its atmosphere when its core cooled and was no longer free to move inside the planet. This caused Mars to lose its protective magnetic field. This left Mars exposed to the solar wind, causing much of its atmosphere to be lost to space. Jupiter and Saturn moved closer and farther from the Sun in their orbits, disrupting the orbits of the other planets and the asteroid belt. Uranus was tilted on its side, possibly by a collision with another planet. Neptune likely captured a large icy object from the Kuiper Belt, which became one of its moons, Triton. The solar system was not stable yet. It was still under the influence of gravity, radiation, and magnetism. It took hundreds of millions of years for the planets to settle into their current orbits and for the debris to clear out. Some of the debris became the asteroid belt, a region of rocky objects between Mars and Jupiter. Some of it became the Kuiper Belt, a region of icy objects beyond Neptune. And some of it became the Oort cloud, a spherical shell of comets at the edge of the solar system. The solar system was finally ready for life. But life did not appear right away. It took another billion years or so for the first living cells to emerge on Earth, the only planet in our solar system that currently has the right conditions for life as we know it. Life evolved and diversified over billions of years, adapting to the changing environment and climate. Life also faced many challenges and threats, such as volcanic eruptions, ice ages, and asteroid impacts. One of these impacts, about 65 million years ago, wiped out the dinosaurs and many other species, paving the way for the rise of mammals and humans. Humans are the only species in our solar system that have developed intelligence, technology, and civilization. We are also the only known species that have explored and studied our solar system using telescopes, probes, rovers, and astronauts. We have learned a lot about our solar system, but we still have many questions and mysteries to solve. For example, how did life begin on Earth? Is there life elsewhere in our solar system? What are the origins and fates of the Sun and the planets? How can we protect our solar system from threats and hazards? And how can we use our solar system's resources for our benefit and survival? These are some of the topics that we will explore in the future as we continue to journey through our solar system, from the Sun to the Oort cloud and beyond. Thank you for watching. I truly appreciate your time. If you enjoyed today's video, feel free to show your support with a like or by sharing this video with someone else who may enjoy it. If you would like to see more videos like this in the future, feel free to subscribe. Thanks again. Until next time, take care and be well.